Pidgin++, the first end-to-end automatic speech recognition system in Nigerian Pidgin. That's nice, amazing. He also has expertise in Python, R, SQL, Python, React, SQL, Python, TensorFlow, and so many more. Okay, so Habib specializes in building high-performance machine learning models for speech recognition, healthcare, predictive and predictive analytics. His work spans both industry and academia, contributing to open source research and AI-driven innovations. Beyond technical contributions, Habib is an active mentor and speaker, having presented at global conferences such as Andela, NVIDIA Upskilling Program, Black in AI Workshop, PyCon Africa, Indaba X, so many more. That's why we said we're going to be having an exciting time listening to him. His dedication to AI and community impact, his dedication to AI, as well as his community impact, has earned him accolades, including the Andela Passion Award. He has also received the Chair Award at IJCNLPAACL. So I think maybe the process of his speaking to us is going to tell us what it fully means. Okay, and he has also made news topic on African languages and recognition as a junior AI ambassador by Global AI Hub. So he's driven by curiosity and innovation. Habib continues to explore the frontiers of AI, pushing the boundaries of language technology, healthcare research, finance, and large-scale data processing. So, Mr. Habib, we are glad to have you. Please, can you go ahead?
Okay, thank you very much, Victoria.
Yes, sir.
And thanks for the introduction. Actually,
we would also like to see you. We are meeting this iconic man for the first time.
Okay, yeah, so I believe you can see me now. Yeah, thank you very much. So, my name is Afolabi Habib. I'm a data scientist, a machine learning engineer, and an AI researcher. So today we'll be talking about the topic, which is machine learning algorithms and their applications. So let me share my screen. Okay. So, like I said, today we're going to be talking about machine learning algorithms and their applications. Please, can you just signify?
Yes, I can hear you.
Okay, yeah, great. Thank you very much. So, like I said, my name is Afolabi Habib. So, our agenda for today includes introduction about machine learning, understanding machine learning algorithms, supervised learning, the digital fortune teller, unsupervised learning, reinforcement learning, deep learning, machine learning in everyday life, and the future of machine learning. So, starting with the introduction, I won't waste much time because I believe we all have some other things to do. Well, we're gonna spend a short time, and I promise it's gonna be interesting and knowledgeable. So let's put it that way. So first of all, introduction. A world shaped by machine learning. Have you ever imagined or wondered how Netflix, Prime Video, Amazon Prime Video, and the likes actually works and the likes of self-driving cars navigate. So here today we're going to be talking about some algorithms that are behind these things. Also, we'll be introducing ourselves to machine learning at first. So machine learning actually is transforming industries and revolutionizing technology. So, but before we can talk about machine learning, so we need to talk about some things that we need to know about that are related to machine learning. So, which includes artificial intelligence. We have artificial intelligence, we have machine learning, we have deep learning, and we have data science. So most people don't really understand what these things are all about. So I'll be giving us a brief um definition or like a brief talk on each of them. So talking about artificial intelligence. So artificial intelligence is more like the machines to mimic human brains. So what artificial intelligence actually is all about is about trying to mimic how human brains works. So we have a subset of artificial intelligence, which is actually machine learning. So machine learning is a subset of AI, artificial intelligence, and builds a model based on training data to make predictions. So while we have the deep learning, which is a subset of machine learning, where deep learning is a subset of ML, a class of machine learning algorithms to solve complex problems like images, texts, audios, videos, and likes. So, and we have data science, which actually got a bit of the three: artificial intelligence, machine learning, we can call it a subset of artificial intelligence, but not completely, because it's an area of statistics, statistic, scientific methods, and the likes, and which extract meaning and insight from our data. So there is something we call domain knowledge, which is one of the very important aspects of data science. So that makes data science a little bit different from the likes of AI, machine learning, deep learning, but you still can do without AI, ML, and DL when you're talking about data science. So, what is machine learning? So, machine learning enables computers to learn from data without explicit programming. It mimics human learning and decision making. So, we have different school of thoughts when it comes to categorizing machine learning. So, some school of thoughts says we have three categories, some says we have four. So I'll be mentioning the two categories. So we have the first category is the three categories, which is this first school of thought, I mean, has three categories, which includes supervised learning, unsupervised learning, and reinforcement learning. While the second school of thought added one more learning, which is semi-supervised learning. So which is more like a combination of supervised and unsupervised learning. So actually, I go with the school of thoughts that states that we have three categories. So that's what these are gonna be based on. So let's move on. So talking about supervised learning. So supervised learning is a learning from it actually learns from labeled data. So most machine learning uses cases revolved around algorithms learning patterns from historical data and are applying them to new data in the form of predictions. These are often referred to as supervised learning. So supervised learning algorithms are shown both historical inputs and outputs. We normally call it teacher. Yeah. So on a particular problem, we're trying to solve where inputs are essentially features or dimensions of the observations we're trying to like predict, and where outputs are the outcomes. So which we wanted to predict. So basically what this actually means is that for our data, the data that is being introduced to our machine will have two things, which are the features and the targets. So we call the features the variables, the independent variables, while we call the targets our dependent variable. So our model is being trained on both data, and we introduce the new data which has only the features to make prediction on, for it to predict our next target, which is our prediction. So based on this, we do some kind of evaluations, and we can evaluate our model and get to know how accurate our model is. So basically it learns from uh both set of data, the features and the targets. So that's what supervised learning is all about. So we have two types of supervised learning. We have the regression and we have the classification. So they are a bit different, but I would explain what each of it is about. So regression uses the use cases are when we try to predict a continuous outcome that falls within a range. So a good example would be house price prediction. So, when you're trying to predict the house price, so the value, your prediction would be in continuous because you don't have a fixed outcome. So take for instance now, you might have a lot of features, you might have a single feature or multiple features. So a house price can be determined by so many features, and the prices will vary based on the features that are being introduced to it. So you can compare the house price of a house that has 2-bedroom flats to that of like 3-bedroom flats. And you can compare the price of a bungalow to that of a mansion. So, and aside that, so there are some attributes, some features that might actually uh, determine the outcome of your prediction. Take, for instance, the area, the location of the houses might actually might actually tell a lot of impacts on your outcome. Take, for instance, now, if you're in Nigeria, you can compare the price of houses on the island in Lagos to that of the one on the mainland, like maybe like Ikorodu, for example, now. So, for example, even a bungalow on the island, or let me say, even a single room apartment on the island might actually be expensive than let's say a duplex at Ikorodu. So that's how it is. So there are so many factors that would determine what your outcome will be like. So that's our regression. So the outcome of your price is continuous because it's not fixed. So it's not a discrete outcome. So, and for classification is the other way around. So classification uses cases are when we try to classify whether an outcome falls within two or more categories. So here we have a discrete category, we have a fixed category, is either yes or no. Or if you have a multi-class, maybe we have like 1, 2, and 3. So it's gonna be predicting between those 3 classes. So a very good example of that is we trying to like classify either trying to build a model that is spam detector model, which is going to be classifying our model to be spam or not spam. So we know what our output is. Our output is going to be a binary output. Is either it is spam or not spam. So this is a discrete output. So this shows the difference between regression and classification. So moving on, here is an example, visual example of a classification model. So we have our model being trained. So we have our data, we have a lot of data, incoming messages. So, and our classification model has been built using the training and our validation data. Then based on what is being trained, the knowledge that has been gathered through our data, the existing data, then it will be able to classify our messages to be spam or not. So the spam will go to the spam and the non-spam will go to the inbox. So that's how it works. So and we have some algorithms that we use for things like this. So we have many algorithms, but we'll just mention the common algorithms, like 5 of it. So we have the linear regression, which is a regression algorithm. We have the logistic regression. Yeah, sounds like it's a regression algorithm, but it's actually not a regression algorithm. It's a classification algorithm. So we have decision tree, which has both. It's a decision based. It's the model is based on tree based algorithms. So we have both. It has both regression and classification algorithm in it. So also we have random forest, which is an ensemble based algorithm, and it has multiple trees in it. So it's actually based on decision tree, just like the name implies, forest. So forest has a lot of trees in it. So that's how. So it has two or more trees embedded in it. So and it's very powerful. It's one of the most popular algorithm out there and very powerful algorithm. So and it has both regression and classification algorithm embedded within it. So also we have support vector and some other algorithms like KNN, K-nearest neighbor. We have the likes of gradient percent. We have some Bayesian naive bias and some other algorithms. A lot of it, a lot of it. So, but we're gonna be talking about these ones. So let's move on. So talking about linear regression. Sorry, are you guys with me?
Yes, we are with you.
Okay, yeah, thank you. Thank you very much. Yeah. There's that double check here. So talking about linear regression, so a simple algorithm models a linear relationship between one or more explanatory variables and a continuous numerical output variables. So it is faster to train as compared to other machine learning algorithms. Its biggest advantage lies in its ability to explain and interpret the model predictions. So, and it is a regression algorithm used to predict outcomes like customer life cycle value, house pricing, and stock prices. So we have two ways that we can actually we can apply linear regression. We have the OLS method and we have the gradient method. So that's basically that about linear regression. So its application cut across prediction of houses and stock prices and the likes. So talking about logistic regression on the other side is more like a linear regression actually. So logistic regression predicts categorical outcomes by estimating probabilities between 0 and 1. Unlike linear regression, it solves classification problem. The name regression at back of the logistic is just formality. So it's actually not a regression model. It's actually a classification model. So it solves classification problem using an S shape. You can see the graph is more like an S shape. So a S-shaped logistic function, it helps classify observation, determining key variables, and it's widely used in machine learning for tasks like this disease prediction and blind binary classification. Logistic regression effectively handles both continuous and discrete data sets, making it crucial tool for probability estimation and decision making in various applications. So, and as you can see, the S slope, we're gonna set a threshold value for it. So the threshold for value will determine the district value. So any value that falls below the threshold will be classified as 0, and any value that falls above the threshold will be classified as 1. So that's how logistic regression works. So talking about the decision tree, as you can see, is a tree that has branches. So the decision tree on the other side is an algorithm, is a tree-like structure, as we can see, of the decision rules that are applied to the input features to predict the possible outcomes. It can be used for classification or regression, like I mentioned earlier. And decision tree predictions provide a good aid for healthcare expertise, as it is straightforward to interpret how those predictions are made. So just like an example we have here now. So we're trying to like predict the color. So the color is actually determined if maybe a customer is gonna buy something or not. So based on some features and attributes, so it's gonna class it, draw branches, and determine. And at the end of the day, it's gonna tell us, okay, yeah, this is due to this, it's gonna be buying or not. So it's a bit something that is a bit I won't say it's a bit complicated, but yeah. So basically, uh you for someone that is just about building model, that is not about decision making, you really don't need to know what's going on behind your decision tree. But if you are working for an organization whereby you're making decisions for them, then you need to understand the decision tree well enough. Like you need to understand what exactly is going on behind your model. How are your features actually, how are they connected? How did they get to arrive to what they predicted? So that would be necessary for you to know. So that's basically about decision. So decision tree is something that is a bit wide. So you need to take your time and study the algorithm, learn about it, and you're fine. So talking about random forests. So I won't lie to you, it's one of the most popular algorithm out there. Like, and that's because of some advantages, some abilities that it has. So it is arguably one of the most popular algorithms and builds upon the drawback of overfitting prominently. So there's something we call overfitting and underfitting in machine learning when you're building your model. So I'll just quickly talk about it. So let me just talk about overfitting, because that's one of the major problems in machine learning. So overfitting is such a way that, let me put it this way. So when you're training your model, we have the training set, we have the test set. So the training set has both the what's it called? It has both your features and your targets. So now when you train your model is able to like train well on your training set. So it gives you like an evaluation accuracy of, let's say, like around 99%. And you're like, wow, my model is doing good. You're happy. So now you introduce a new data set that it hasn't seen before to it. To like around 65. Yeah. What just happened there shows that your model is overfitting. Sorry, can you hear me? Are you with me?
Yes, we are with you.
Okay, I agree.
Yes. Yeah.
So what just happened there is overfitting. So and when your model is overfitting, then there is a problem. So and you need to find a way to deal with it. So one good machine learning algorithm model that can actually handle that very well is random forest. So that's why it's one of the most popular algorithm out there, because it has what it takes to handle everything. So like I mentioned, random forest is built based on so many trees. As we can see, we have tree 1, tree 2, tree 3, tree 4. Like it's very, very powerful algorithm. So that's about that one. So let's talk about support vector machine. So support vector machine on the other side It's commonly known as, yeah, SVM. We call it SVM, or it's support vector machine. So, and generally used for classification problem. We have regression. So, the for classification problem, we call it SVC, which is support vector classifier. And for regression, we call it SVR, support vector regression. So it has both regression and classification model. Just like random forest has that as well. It has both algorithms, regression and classification. So SVM finds an hyperplan, as we can see in this figure. So it's find an hyperplan, like a line that is this line that is, in this case, I'm talking about this line. So it finds an hyperplan which segregates the two classes, red and green. So, and maximizes the margin, which is the distance between the dots lines between them. So SVM is generally used for classification problems, majorly used for classification, but it can be used for regression as well. So it uses to classify new articles and handwriting. It's used in classifying news articles and handwriting recognition. So that's basically it about support vector machine. So I haven't talked about the common machine learning algorithms for our supervised learning. So now let's talk about unsupervised learning. So unsupervised learning is used for discovering hidden patterns. So instead of learning patterns that map inputs to output like the supervised learning, where we have our features and targets, so unsupervised learning algorithm discover general patterns in data without being explicitly shown outputs. So the way it works is just like it has only features, it doesn't have targets. There is no target here. We don't have any targets. So it's just the features alone. So and what it does is more like it classify your data. So let me show you an example of that. So we have an unlabeled data here. So, and this is our machine, which is our unsupervised machine learning. So what it's gonna do is that it's gonna classify, is like going to categorize the ones that are, the shapes that are like similar to each other. So as you can see, the ones that are more like rectangle are packed to one side, circles, then the what's it called? The hexagon and the triangle. So that's basically what unsupervised learning does. So, and we have some algorithms. We have a lot of algorithms that can be used. We have, but the common ones are the likes of k-means clustering. We have the principal component analysis, PCA. So, example of where we can apply unsupervised learning is customer segmentation in e-commerce based on shopping behavior. So, you might be wondering, there is something we call a priori, and we have something we call market basket analysis. So these are some example of unsupervised learning. So I don't know, like let me use a very close example of unsupervised learning, something that we are familiar with. So a good example is what's it called, is supermarket. So the way they does their thing. So though it's a bit more of like supervised learning and a kind of recommendation system, kind of, whereby, take for instance, where you see breads, you will have different breads. Yeah, fine, different products of breads on a counter, on a what's called a shelf. I mean, so but you see them being laid together. And very close to them, you will see things that goes along with bread. So not far from it, the likes of like maybe what's it called? The likes of milk, beverages. Let me just put out beverages, the likes of butter, margarine, and the likes. So you see them close to things like this. So this is how the trend goes on. So things that are related to each other would be closer to each other, like they will find a way to like classify them so that they will be very close, arrange them in a very close manner, whereby even things that you might have forgotten before leaving home, when you get to supermarkets, you'll be like, okay, yeah, okay, I bought these, and you can see things that you've been needing for that thing, or things that can actually go with it on the next shelf. So that's just a little bit of a example for that aspect. So yeah. So K means clustering. So talking about K means clustering. So K-means clustering is the most widely used clustering. So we have some other clustering algorithms. So we have the likes of hierarchical clustering and some other clustering as well. So, but it's the most widely used. K-means is the most widely used clustering. So it determines the K clusters. So the K clusters is the number of clusters that we want to have. So as you can see here, we have 3 clusters. So we have one is this blue, we have the green cluster, and we have the black cluster. So we have 3 clusters in this case. That's the number of our K. So we can determine the number of our K ourselves. So it's going to group the data that are closer to each other. So it uses what we call the Euclidean distance. So this Euclidean distance is what is being used in KNN as well. So and it uses it to group the data. It is a very popular algorithm for customer segmentation and recommendation system, like I mentioned earlier. So also we have principal component analysis. So it's basically used for dimensionality reduction. So principal component analysis is a statistical procedure that is used to summarize the information from a large data set by projecting it to a lower dimensional subspace. So, and what do we mean by this? So this, take for instance, we have a lot of features in our data set. Maybe we have like hundreds of features. So, and we like really don't know how we can deal with it. So we can apply principal component analysis to reduce it down to like maybe 5 dimensions, 10 dimensions, depending on us. And it's going to like all the features that we have in all these 100, the algorithm is going to streamline it down to the 10 dimension or 5 dimension. So you can determine your dimensions. So it can be 2, it can be 3, it can be 4. So this example now we have 2 dimensions. So we can have more dimensions. You can have 5, 8, 7 dimensions depending on you. So that's what principal component analysis does. So it is also called dimensionality reduction technique, which ensures retaining the essential parts of the data with higher information. So that's basically that about clustering. So, and the third category of our machine learning is what we call reinforcement learning. It is learning through rewards. So sorry, are you guys following me?
I'm kind of following. This is great though. Thank you.
Okay, great. Is there any question before I move on?
Not from me, no, thank you.
Okay, great. Yeah,
I don't. We will take.
So, okay, let me move on, I guess. Okay, so we have reinforcement learning through rewards. So in this case, the algorithms are trained just as humans learn through rewards, and our penalties, which are measured, are tracked by reinforcement learning agents, which has a general understanding of the ability of successfully moving the score up versus moving it down. So let me use an example that I am using a lot when it comes to reinforcement learning. Very easy one. So this is how reinforcement learning are used in the likes of robotics, video games, and some other things. So the way it works is such a way that okay, take for instance you build a robot with reinforcement learning. So one thing is that it has the ability to learn on its own. So now maybe you put it, take for instance, you put it in a squared room now. So at a starting point A, and is supposed to walk around that room, around the corner of that room, and to the starting point, back to the starting point. So what the robot is gonna do is that to start from point A, move straight down to point B. So the moment it hits point B, it's going to hit an obstacle because there is a wall at that point B. So what he's going to do is that he's going to trace back again. He's going to relearn, go back to the starting point and start learning again. But at that point, so that I've learned that, okay, yeah, in 10 meters, I encountered an obstacle. Then it would have calculated, okay, that means I will have to make a turn when I get to point B. So now what it's going to do now is either of two ways. When it gets to point B, again at 10 meters, it tries to make a turn. So if it makes a turn to the right and there is an obstacle on the right, it goes back to the starting point again. At that point, it has learned that there is an obstacle at 10 meter going front, and there is an obstacle if I try to turn to the right. So the next turning will be the left turning. So when it gets to 10 meters, it's going to turn left. So at that point, he has been able to achieve the goal of point A to point B. So now it's now left with point C. So now it's continue moving until it hits another obstacle at point C. So when it hits another obstacle at point C, should have learned that, okay, I hit something here. Then go back to the beginning again, point A, and learn the path through. So it repeats it until it's able to reach the end point. And at that point, you would have learned how to walk around that room. That's basically how reinforcement learning works. That's like a basic example of it, how robots learn. So that is why the same way they learn when playing games, video games, and some other things. You can imagine if you are playing, I don't know, people that play PES, what's it called? So if you notice, if you start playing with your computer, initially you might be winning it, but at some point it will get harder at some point. What happens is that the computer is actually learning your game. Is learning and relearning your game until it gets to a point where you won't be able to beat it anymore. So that's the essence of reinforcement learning. So we have what we call trial and error. So that's just basically what reinforcement learning is, or that's the basic thing about reinforcement learning, trial and error. So through trial and error, the agent learns to take actions that lead to the most favorable outcomes over time. So reinforcement learning is often used in the resource management, robotics, and video games. So we have algorithms like Q-learning, deep Q network, and some other learnings. So this is an example of reinforcement learning. Agents, we have an action, the rewards, observation. So that observation is very important. So it's take an action, get the rewards for it, and it observes. So basically, it's an agent being thrown in an environment, in new environments, to learn about what is going on in the environment. So that's about reinforcement learning. So I haven't talked about machine learning. So we have a subset of it, which is deep learning. So it won't be really nice if we talk about machine learning. I will mention deep learning a bit. So deep learning is the brain behind AI. So deep learning is a subset of machine learning. It learns from labeled or structured data, automatically extracting features. It reduces humans' intervention and enables large data sets, making it effective for tasks like image recognition and natural language processing. So one major difference between deep learning and machine learning is that Machine learning can actually deals not it actually deals with a small data set compared to that of deep learning. Deep learning deals with a very large amount of data set, very large amount of data set. It can actually handle the likes of image. Can imagine how image data is very heavy. Images, videos, audios, speech, text, on and on. So so we use image recognition, is used for image recognition, natural language processing. So we have a lot of algorithms that we use on